Hi, it's Joseph from My Tutors London, and today I'm going to be going over a bit of trigonometry. Now, there's a lot of topics in trigonometry, so the one particular topic which I'm going to be going over today is drawing the trig graphs, specifically the cos and the sine graphs. I'm just going to start with cos, but everything that I'm going to show you with the cos graph also applies to the sine graph. So first off, we'll just start with the generic graph y equals cos of x. So we know that this graph is something like this. It starts at 1, it gets as low as -1, and go 360, 180, 90, and 270, and it's going to oscillate between these points as shown. Okay, so there's our regular cos graph. Now what we're going to go over today is the different ways in which we can change the cos graph. And there are 4 ways we can change it. We can change it by putting an a out the front of it, which is just a number like 2 or 3 or 4. It can also be a fraction, it can also be a negative number. Another way we can change it is by putting a number inside these brackets next to the x. I've written it as b. Again, that can be that can be the number 2, 3, 4. It can also be a fraction. It can also be a negative number. The third way of changing it is by going plus d. Now this is not inside the bracket, so this is cos of x and then plus d on top of that. And d can also be negative, so it can be, plus 5 or take away 5, or plus 10 or take away 10. And then you can also have a number being plussed inside the brackets, and I've made that plus c. So that's that's like inside the brackets, and again that can be negative or positive, so it can be plus 5 or take away 5. Okay, so the first one we'll have a look at is this top one here, a cos x. So I'm going to choose 2 cos x, nice and simple. And the way this changes the graph is it changes the graph to go from 2 to -2. And that's 0. Put 0 in there as well. So every x value is the same. You've still got the 180 and the 90 and the 360 and the 270, but instead of oscillating from 1 to 2, instead of oscillating from 1 to -1, made a mistake there, instead of oscillating from 1 to -1, it oscillates from 2 to -2. So here's what the graph would look like. So the basic change that has occurred is that each y value has been multiplied by 2. As you can see, we originally had the point 0, 1, and if the y value has been multiplied by 2, we now have the point 0, 2, which is that point there. Okay, so the next graph we're going to have a look at is, I'm actually going to go to this one first. I'm going to go to this third one here, which is the cos x plus d. So an example of that one I'm going to do is y equals cos x plus 5. So here's how this one would look. Drawn it a bit bigger this time because it's going to have values up here. So that's going to be 5, 6, and 4. Okay, so it's going to start at 6, and we'll just draw the 360, 180, 90, and 270. And there, and there, there, and there. Okay, so what's happened here is, if we have a look at the original graph, cos of x, you can see that although it goes from 1 to -1, the kind of middle line of the graph is 0, y equals 0, the x-axis. But now that middle line, because of the plus 5, that middle line has been shifted up from 0 to 5. So that is our kind of middle line. Now this dotted line isn't actually on the graph, but I'm just putting it in for reference. And likewise, similar to this one, you can see that from the middle line this one goes up 1 and down 1 to 1 and -1, but this one also does the same thing, so it goes up 1 to 6 and eventually it gets as low as 4, down 1 to 4. So that's how that one changes, and a way that we can describe that is that each y value has been increased by 5. So if we originally had the point, I'll use a different point this time. If we originally had this point here, which is 270, 0, we originally had that point. Each point's been raised, so we now have the point 275. So as you can see, the y value has increased by 5. Okay, next piece of paper. Okay, the third one that I'm going to have a look at is y equals, I can see that's a bit high actually. Okay, put it down to there. Yep, y equals cos of 3x. So that is an example of putting a number inside these brackets next to the x. Okay, so just before we continue, I just want to introduce to you a concept called the period of a graph. So if we have a look at this original graph here, the period of the cos graph, and it's the same for the sine graph, is from where it's at its peak, it's gone down, up again, and then it's gone back to its peak. So we can see if we look at this graph that the period equals 360 degrees. It's how long it's taken for it to start somewhere, do a full cycle, and then come back to that original spot. So what happens when we put a 3 or any other number inside those brackets is the period becomes divided by that number. So the period in this case will be divided by 3, so the new period is 120 degrees. So if we have a look at this graph, the y values are unaffected, still goes from 1 to -1, but it no longer goes, okay, well I'll just draw it, so 120, 90, no, made a mistake there, that's 60, 30, and 90. Okay, and so starts off at 1, goes to there, goes to there, goes to there, and goes to there. Okay, so that's how it's changed. So originally that was 360, now it's 120. Originally that was 180, now it's 60. Originally that was 90, now it's 30. If you compare that to the, if you go back in the video and compare that to the original graph that we had. So basically what's happened is that each x value has been divided by 3, divided by whatever number we had up here. So if you imagine originally, I'll just go back to the original graph. I use a different point to the ones I've used previously. We had a point here, 360 degrees, comma 1. That was that point, 360 degrees, comma 1. I'll write that point again. We originally had this point, 360 degrees, comma 1, and now we have this point, which is 120 degrees with a y value of 1. So as you can see, the x value has been divided by 3, and this is true for every single point on that graph. Okay, let's get moving. The last one that I want to go through is y equals cos of x plus 45. So that's where you've added a number inside those brackets. Okay, so that's what. So let's have a look at what this graph looks like. Oops. Okay. So this graph, I'm just going to have to make it a bit more finer detail here. So we'll go 360, 180, 90. Okay, so you can see I've put in some extra lines here. I've still got the 360, 180, 90, and 270, but I put in extra lines to show 45 degrees, 135 degrees, and basically the midway points between each of those. So what's happened with this one is, you imagine if we put 0 into here, then that's 0 plus 45. So really, if x is 0, you're doing cos of 45. And cos of 45 is not 1, it's square root 2 over 2, so it's somewhere up here. And you can imagine that if we put 45 into here, that will then be 45 plus 45, which will be 90. And we know that cos of 90 is 0. So we actually reach 0 45 degrees earlier. So then it will go back up to 0, it will get down to 1 here, go back up to 0 here, and it will reach 1 here. So I'll just draw what this looks like. Okay, so what's happened with this graph is each x value has been reduced by 45 degrees. If we go back to the original graph, you can see that the first time, the first time that we reached -1 was at this point here. So that point was 180 degrees, comma, -1. But I'll write that point again. So we originally had this point, 180 degrees, -1. But then if we have a look over at this graph here, it reaches -1, the low point of the graph, at 135 degrees. So we now have the point 135 degrees. So the corresponding point, the minimum point, has had its x value reduced by 45 degrees, and that will be true for every single point on this graph. You can see it originally, I'm sure you can see on the original graph, if you go back in the video, that it originally reached 1 for a second time, you know, the second peak of the graph, at 360 degrees. But now it reaches it at 315 degrees, so it's reached it 45 degrees earlier. Okay, so that is the 4 different variations that you can do to the cos graph. I just want to say that you can apply more than one at the same time, so you could have y equals a cos bx plus c plus d. So more than one can apply. You don't necessarily have to have all 4 at the same time, but you can have 1 or 2 or 3 or 4 at the same time. I will also say that the same rules apply to the sine graph. So you can have sine of x, and you can also have the same changes occurring, a sine brackets bx plus c n brackets plus d. And I will just reiterate that a can be, we've used a as being 2, but a can be a negative number and it can also be a fraction. We used b as being 3, but b can be a negative number and it can also be a fraction. We use d as being 5, but d can also be a negative number, and we use c as being positive 45, but that can also be a negative number as well. Okay, it's not the best graph in the world, but you get the rough idea. Okay, cool. So, now it's going to be, the general formula is going to be a trig function, which we don't know if it's sine or cos yet, of bx plus c plus d. Okay, so to start with, I'm going to start with finding the middle line. Okay, so the middle of this graph is at -1, so that means that the d is -1. So if we just I can tell that this is -1. Now, deciding whether it is a cos graph or a sine graph, the cos graph starts at the highest value, whereas the sine graph starts at the middle value. So I know that this one is a sine graph. Now, from the middle value, it's gone up to, from -1 to 1, and it's gone down to, from -1 to -3. So that means that this a is going to be 2. Okay. Now, it's the sine graph. It hasn't been shifted across to the left or across to the right. So that means that this plus c is 0. So I'll write plus 0 just so you can see, but in reality we wouldn't write anything at all. We would just cross it out. And now the final thing is, what is this b? So I'll already put the x there in anticipation. But, okay, we're going to have, what is the b value? Okay, so if we see here, this has done one full cycle. It's started somewhere, it's gone up, it's gone down, it's come back to the original position. And that would obviously, as we know, it would just continue cycling as the angle gets bigger. But it took 180 degrees to do the full cycle. So the period equals 180 degrees. And as we remember, the period equals 360 degrees divided by that number that we put next to the x inside the brackets. So what must that number have been in order for it to equal 180? That number must have been 2. So the full answer for this graph is y equals 2 sine of 2x, take away 1.